Alrighty, welcome back. This is chapter 1. For this chapter, the main idea is to get a feel for what everything looks like, what everything is called, the vocabulary of this first chapter, because it's essential that you know it before we actually start using some math along with it. So, we're going to go through this. The term's already there, the name's already there, the diagram is what we're going to draw. I'm going to talk you through a couple things that are important as we go. So the first thing we're going to look at is a point. You guys probably can already figure out what the diagram is. But it's a location that is represented by a dot. It doesn't have a size, but it's a location that's represented by a dot. So we would say that that dot or that period there is a point. It represents a location. Now we draw a period, but it doesn't actually make it something that's physically there. Just think about if you were to drop a pin on a map on your iPhone or something like that. It's not actually there. You're just talking about a specific location. So as we look at these, we're drawing them so that we can look at them, but they don't actually exist. They're not solids. They're invisible, if you will. So the second thing we're going to look at is a line that is a straight path, that it has no thickness and extends forever. So that's going to look like this. Again, we're drawing it so that we can look at it, but it doesn't actually exist. It's not there. It's invisible. Okay, it doesn't have a thickness. We would label this line like this, A, B. Okay, that's one way to label it, A, B, or BA, with the arrows above like this, going both ways. Or you might see a lowercase l, something like that. Okay, either one works. You could label it either way. Next thing is a plane. It's a flat surface that has no thickness and extends forever. Again, it doesn't actually exist. It's not physically there, but it's on some sort of plane. Okay, that's the way we'll draw planes most of the time. That's what you'll see. We'll look at some 3D ones as well at some point. It's represented by either some script, capital letter, like some fancy, let's see if I can even draw it, some fancy R like that. That's one way. Okay, or you're going to see 3 points that are not on a line. So you can't draw lines through those 3 points. Okay, either way is acceptable for the plane. You'll see both. The next thing is a segment. It's like a chunk of a line. So instead of extending forever, it just stops. Okay, you can label it AB or BA. Okay, everything in between is part of that line segment. Again, notice how that notation is above those letters. It's important that you have that correct. Next thing is an endpoint. All this is a point for a specific location. So if this is C and D, both of these are endpoints. Okay, it's where it ends at. We don't have a beginning point. Next thing is a ray. Immediately, hopefully, something comes to your head like a ray of light. Okay, ray is a part of a line that starts at an end point. Again, there's no beginning point, and goes forever one way. Okay, just like the sun, it starts at the sun and then goes forever towards us. Okay, we would label this R, S. Again, notice the notation. It starts at R and goes to S. You would not label this SR that way. That is incorrect. We cannot do that. Okay. Last thing is opposite rays. So those are 2 rays that have a common endpoint and form a line. So they have to share some endpoint. Look at the notation here. EF and EG. They're sharing E, so we know E is in the middle somewhere. And then we can have a ray going this way. We'll call this EF. Okay, and we can have, since it's an opposite ray, we're going to have EG going this way. Okay, again, they both start at E and go off in opposite directions. Now, before we go any further, let's take a moment to hear from our sponsor.
What's better, faster or slower?
Faster!
Yeah, what's fast?
My mom's car and a Chia.
Okay.
A spaceship.
Spaceship. And what's slow?
My grandma's slow.
Would you like it better if she was fast?
I bet she would like it if she was fast.
Maybe give her some turbo boosters.
Tape a cheater to her back.
Tape a cheetah to her back.
And
Seems like you've thought about this before.
It's not complicated. Faster is better. An iPhone 5 downloads fastest on AT&T 4G.
Alright, and welcome back. The last couple things we're going to look at are postulates. You don't need to worry about remembering which one goes with which, like 1-1-1, 1-1-3, all that. So just make sure you understand what it means. And this is where it gets a little bit complicated, and you have to pay attention to what I'm saying. And if you have any questions, let me know tomorrow. First one says that through any 2 points, there is exactly one line. So if we drew some point here, we'll call it A, and some point here, we'll call it B. We can draw a line straight through those points. Now this is where it gets tricky. That makes sense. This is where it gets tricky. Sometimes you're going to see diagrams like this, and they're not labeled with another line going from B to C. However, you could still draw a line from B through C. It's not there, but you could draw it, and it's important you understand that. Next thing, through any 3 non-collinear points, there is exactly one plane containing them. What that means is that, like here, and the one we just went over, A, B, they are collinear. Okay, they share a line, just like collinear or co-worker would be share a job. Collinear, they share a line. When we have 3 non-collinear points, so if we had something like point here, point here, point here, where you can't draw a line through all 3 of those, not one straight line, that's what we call a plane. Okay, there's a plane on through those points. So think about if you were maybe just setting up 3 balls on a driveway, you could lay a plane on top of them or through them almost. Okay, however you want to think of it, that's what it is. So any 3 non-collinear line or points rather has a plane going through it. The next thing, if 2 points lie in a plane, then the line containing those points lie in the plane. Okay, so again, if 2 points lie in a plane, so let's draw a plane here. So if we have some point A and some point B, and they lie in a plane, then the line containing those points lies in the plane. So if there's this line going through the plane or along that same angle, the line's in the plane. If the 2 points are in the plane, line going through those points is then also in the plane. Last couple, and then I might even add one. If 2 lines intersect, then they intersect in exactly 1 point. So if you're looking at one line, another line here, they intersect at some point. Makes sense. If you pull 2 pieces of string across each other, they're going to meet at exactly 1 point. Or just like algebra last year, you're drawing 2 lines, they intersect at exactly 1 point. Again, those lines don't actually exist. The point doesn't actually exist, but we refer to it as those. If 2 planes intersect, then they intersect in exactly 1 line. So let's see if I can draw something 3-dimensional. Okay, we have this, and then we have some plane kind of going through it. Okay, so we have this plane. So try and imagine that that's 3-dimensional. Where they intersect at, which would be really right along this line here, that's a line that they intersect at. So unlike the 2 lines that intersect at a point, 2 planes intersect at a line. If you look in your room or wherever you're watching this, if you look at your floor and the wall, they intersect at a line, not a point. It's kind of like an edge. Okay, the last thing that I don't actually have on here, but I'd like to mention is if a point or if a line and a point or a plane meet rather. So if we had something like, here's our plane, and we had some line going through that plane, it's going to intersect it at a point. Okay, so you kind of have to visualize what's going on. 2 lines intersect at a point, 2 planes intersect at a line, and then finally a line intersects or goes through a plane at one specific point. Okay, make sure you look over these, make sure you have this sheet handy until you know these by heart. We'll take any questions tomorrow in class. Have a wonderful night.